Welcome to an introduction to Pandas. What is Pandas? Pandas is fast, powerful, flexible, easy to use, and open source package. You will use it for data analysis and manipulation, and it's built on top of the Python programming language. You can find more on the Pandas site. So before we dive in, you will need a basic knowledge of Python. However, I got you covered. This is a 1-hour full hands-on code first tutorial, and it's completely free. You can find it on YouTube. Getting started with Pandas. First of all, you will need to have Python installed. However, if you use Anaconda for this installation, the Pandas library will be pre-installed. Second, you will need a code editor. In these tutorials, we are gonna use Google Colab. Third, you will need to import Pandas in code. You can find more about getting started with Pandas on the original site. So, where is Pandas useful? Pandas is useful for tabular data like SQL tables and Excel spreadsheets. You can use it with ordered and unordered time series data. It can be used for matrix data with row and column labels. Finally, it can be used with various datasets, and you will not need the data to be labeled for them to be used in a Pandas data structure. What is the basic data structure of Pandas? It is the data frame. Data frame is a matrix with rows and columns, and each column is a data structure called series. So a data frame is a container for series, and series is a container for scalar. Okay, so let's dive into code. Here I have my Google Colab environment, and what I want to do is start off by importing Pandas as PD. Essentially what you do is load the package of Pandas with the name of PD. I press Shift Enter to run this code cell. After that, I'm gonna create my first Pandas data frame. This is really easy. I'm gonna be copy pasting the code. In this dictionary, for each key, we're gonna create a column. Let's visualize the result. Shift Enter, and this is how the data frame is gonna look like. We're gonna have 3 rows and 3 columns. The first column is named name, the second age, and the third sex. As we've said before, each column of the data frame is a Pandas data series. Let's access the column age. You can see the name of the column, its data type. If I use the function type and then put inside of it the df age, we can see that the type is pandas.series.series. Quite nice. And we can also initialize a new series object by just calling the pd.series, specifying the elements. So let's say we got 3 numbers, and also specifying the name. So let's call it age. We're gonna assign the series into a new function called ages and print it out. What we've done is essentially created the ages column. Okay, so this was a very short video on an introduction to Pandas data frame. You can see these 2 other videos to select a subset of Pandas data or reading data from file using Pandas. Go check them out. So in this tutorial, we're gonna see some basic Pandas operations. We're gonna see the .head, the .tail, the .d types, the .shape, .describe, .info, and the type. So let's dive into code. What I want you to do is import Pandas as PD. This is the first step. Secondly, we're gonna create a data frame, which is the pd.dataframe, and you are gonna be creating this data frame. Let's try and use the .head operation. First, we're gonna be using the .head operation. .head essentially returns the first n rows of the data frame. So here we specify then equals 1. So it's gonna return the top row of the data frame. Boom. And we got this. You can also use the .tail operation, which does the reverse. It returns the last 10 rows of the data frame. Let's run this. Boom. And we get the last row of the data frame this way. Then we got the .d types. What this operation does is that shows the type of each of the columns of the data frame. So we've got name, which is an object, age, which is an integer, and sex, which is an object. After that, we can use the df.shape operation, which returns the dimension of each axis of the data frame. So we got 3 rows and 3 columns. Then we got df.describe. So df.describe returns some statistics for the data frame. Statistics can be used only for numeric variables, so we only see age here. So we see the count of elements, the mean, the standard deviation, the minimum value, some percentiles, and the maximum value. Then we've got df.info. df.info returns some information about the data frame object. For example, how many elements are non-null, meaning non-missing, what are the names of the columns, what are the data types, and essentially some stuff about usage, some information about the columns and the indexes of the data frame. Then you can use the type to get the type of the data frame. So the type of the data frame is going to be an object of type DataFrame. These are the basic operations for Pandas. You can check out these other two videos to get more information about Pandas and their use cases. So welcome to this very quick and short tutorial. In this tutorial we're gonna see how you can read and write Excel files in Python Pandas. So the first thing you want to do is import Pandas as PD. So after that, suppose that you create a new data frame. Type in this data frame and visualize it. Okay, so let's write this Pandas data frame into Excel spreadsheet. What we're gonna do is use df dot to Excel specify the file name, which we're gonna name.xlsx. We're gonna specify a spreadsheet name, which we are gonna call blah blah, and we're gonna specify that it will not have an index. So if we run this code cell and open our file folder, we're gonna see a name.xls file. If we open up this file, we're gonna see that it has the 3 rows specified. Boom. Now let's suppose that we want to read this file. What you want to do is use pd, meaning pandas, read Excel function, specify the name and the spreadsheet name. Let's read this. Boom. And we've got the XLS file read, and you can use this equal to a df2. So you read the file and store it into a data frame. Let's run this code. You are good to go. Hopefully this tutorial was helpful. For the next steps, you can see those two tutorials. Read data from file using pandas, for example CSV files, and also select a subset of pandas data. Okay, so in this tutorial we're gonna see how you can read a CSV file in Python using Pandas data frames. So Pandas is a library used usually with Python, and it's the most prominent library that you use for data analysis. So the first thing you want to do is to write import pandas as PD. This way you import pandas and you name this library as PD. It's a naming convention that you will usually see. After that, you need to see your working folder. My directory has the sample data folder, and I have some CSV files here. As you may know, CSV files are files that are comma delimited, meaning they are separated by comma. And here you can see an example of how it looks like. It's just an Excel file. If you are accustomed to Excel, it's a sheets file. So let's see how you can read it. What you want to do is, after importing pandas, let's run this code cell. What you want to do is use pd, meaning pandas dot read underscore CSV. This is a function that you are gonna use from the pandas library to read files, and they can be either CSV files or they can be anything you could actually want. So the first argument that you need to specify is the location of the file. So in my case it's sample data and then nist test.csv. So boom, so I've specified the name, and boom, here you can see that I have read this file. For example, let's check another file. I will try and import the California housing train, and you can see here that the dataset is imported, and also the column names are also important. One very important thing that I want you to learn is that you can specify the separator argument. CSV files by default are separated by comma, but you may have a file like a text file that is separated by tabs. What you can do is specify here the character of tab, which is slash and T, so you can read it with tabs. In our case, you can see that it's gonna be written in a wrong form because we want comma here. And there are also a lot of other arguments on read CSV that you can see. So for example, if you go to the documentation of Pandas, you can see that it has so many arguments. But the basic one and the first one is the file path. Then you specify the separator, the default value is the comma. And then you can specify where the header is. For example, if your header file, meaning the column names, are not in the first row, you can specify a different row. And you can also specify the name. So for example, if you want to specify different column names from the ones in the file, you can use the names equals something to do that. If you also have an index in your data, you can specify the column of the index. So let's check it out a little bit. Okay, so let's do that, and let's say that the index will be the longitude. So if I come here and put index call equals true, let's check it out. Okay, so this does not work. So let's check out false. So false probably is the default, but you can also specify it, I think, like longitude. So let's check this out. Boom, and I specified that the column name called longitude is gonna be the index. All right, so this is really helpful if you know the index of the files. For example, you may have an ID or something like that. So this is how you can read pretty much any file in Pandas, except for JSON files, of course. You can specify the separator, which separates the data. You can specify an index call, and you can see that you can by default get like your column names, and how you can use, for example, the names or the header to change your names. There are also a lot of other stuff that you can do, but just for now, I think that this is pretty much okay. You don't need all the other stuff here. They're, a bit more customized, but you can go ahead and, read the documentation. Today we're gonna see how you can filter columns and rows in Pandas data frames in Python. So the first thing you want to do is to import Pandas, of course, and we're gonna import the Pandas as PD, and then we're gonna load in a CSV file. I'm on Google Colab, so I have access to the California housing train. Yours could be different. So let me run this code so you can see my file, how it looks like. Okay, great. So the CSV file is loaded in, and let's see some filtering operations on columns. So let's say that we want to filter the column of latitude here, and we actually want to keep only the values of latitude over 40. So we are gonna keep only the rows that for the latitude column, they have the value of 40, and drop all the others. So first of all, what we do is call the name of the Pandas data frame, then put brackets, then again, from the Pandas data frame, we use brackets and access the column we want. So in this case, we want latitude. So here, what essentially we say access the latitude column, and we want to keep only the values over 40. Okay, so this will create a mask matrix of false and true. And by calling this back on our file, what it will do is only keep the rows where the latitude is over 40. So let's print it out. Boom. And as you can see, from the 70,000, we go to only 338 rows. And we can see that for each row, the latitude is over 40. So this is one of the filtering operations that you can do on numeric or integer data. The next one will be a little bit more complex. So for this case, we want a data frame where we have string value. So I have one already made. You can see it here and copy paste it on your code. And what I'm gonna do is like run this code and see, let's visualize this data frame. So let's say, for example, that we want from the column first to keep only the rows that take the value of yes. How are you gonna do it? So again, we access the data frame by calling the name of the data frame, then again brackets to go and access the rows, and then we do our file too, again brackets because we want specific values for a specific column. So what we do here is for the column first, and we're gonna call it here like a string, we want to keep only the values that take the value of yes. So if this column is in, and then we put a list here that's called yes. So if this column takes the value yes, and it can take multiple values. So for example, if we want to keep also the rows that take the value of no, we can use in this list, because this is a list, we can also use the value of no, the string no. So if I run this, please tell me in the comments what you believe the output would be. Okay, so the output would be this row and this row. and this will be dropped. The middle row will be dropped. So if we run this, boom, you get the first and the third row. Amazing. So let's say that you only want to keep from the row first, you want to keep only the rows that take the value, that have the value E inside of them. So you do not want the whole string to take a specific value, but you want only the columns that have the character E inside of them. So for example, you may want to do something special on this file. So what you do is use our file 2 again. You see a pattern here. What you do is use our file 2 again, brackets, because we want to access specific stuff. And then again, we use and access the column first. So that's pretty simple. And then after that, we call the str method and then contains. So essentially what we do is we get from the str the method contains. And in the method contains, what you want to do is just put the character. So what we ask is for each row and element of this column, we want to access each string and see if it contains the value of V. So which rows of the first column have the value E inside of them? Correct, the first and the second. So this code will output the first and the second column. The first and the second row, sorry, and all the columns. This is amazing. So we've seen how we can filter data using a list of values, using a specific character, and also using some numerical comparison. This is absolutely amazing. So this is great. So now let's suppose that your data frame has also an index. So let's set up our file 2 to have an index. So our file 2, what we do is set underscore, call this method index, and then what we do is we are going to set the first column as an index, and we are gonna do it in place. So if you have an index on our file 2 or your data frame, let's see how you can use it. So okay, we already have the index set up. So okay, we're gonna print our file 2, and you see this time the first has become the row index. So how can we filter using the index? First of all, I'm gonna do something very simple. I'm gonna call our file 2.filter. This new method that we are gonna learn, and I want only to get the second column. So if you only want to get the second column out of your data frame, what you do is use filter, and in the items, put in the list only the name of the second column. So boom! Here you see a new instance where we have the previous data frame, but only with the second column. Now, this code is equal to the code I'm gonna write here. So this is equals to the axis equals to 1. Axis equals to 1 mean that the item is gonna use on the column. So we say that these items are in the column. Now, if we only wanted to select using the rows and specific values that the index takes, what we do is take this code, okay, and in the items, let's say that we want the yes, so we want only to keep the first row. And we are gonna turn also the axis equals to 0, so we do a search using the rows. Let's check this out. So now we have only the first row, which takes the values of yes, so we filter out everything else. And we return also the other two columns. Amazing. Isn't this really, really amazing? Now, let's say that we have our file 2, and we want to filter like we did in the previous section, where we want to filter by using a character here. So we can use the attribute like, the argument like, and equal it to a character. So again, we want to use axis 0 because we want to do this for the rows. So if you only want to keep the rows that have a character E in their index, what you can do is use this argument here, like equals E, axis equals to 0, and if we run this, we will see that we keep only the first and the second row. And you see it here. Yes contains C, maybe contains C, but no, this index does not contain E, so it's dropped from the data frame. Amazing, right? After I finish this video, go back and review everything that I've shown you. Now, let's see another beautiful method that I like to use, and I usually use this method. So let's say that we want to access only the second column. What you can do is use the name of the data frame and brackets, and then you have the column name. Boom. And here we are going to get the output of the column name. This will be a Pandas series object. And I'm not going to go into what a Pandas series object is, but essentially it just refers to a column of the dataset. Also, you can see here that using this method, the index is also returned into the series object. And here, the name of this series object is second, the data type is object, and we also have the first, the index essentially, and these are the values that this column has. So essentially, it is this part of the code you can see here, this small part. Now, let's say that we want to access our file too and just take the rows that take the value of yes. So we want the index yes. So from the rows, we're going to select the first row, and we also want to keep now the second column, which is named third. So if I call this, we will get the first row. Okay, so I made a small mistake here. You want to use the attribute lock. So using lock, you can use strings to access specific positions. So by using the string in the first position, we access the row with index yes. With the second position in this bracket, we use it to access the column name we want. And the lock is used, this is used only with string values. Okay, so in these brackets, you only input string values, so lock can work. Another way, let's say for example that we want to get all the rows of the third column. What you can do, okay, so the name here is not correct. What you can do is use this notation. That means get me all the rows of the third column, of the column named third, which is the second column right now. So if I run this code, we will get, again, a series. So this is kind of equivalent to this one. So if I go here and use second, we will see that the output will be the same as here. Okay, so these two ways are exactly the same. Second way. Okay, and again we get a Pandas series object. Let's move on. Let me run this. So there is another way you can access and slice and filter a data frame. The second way is using integers. So instead of using the strings, what we do is call file2 with ilog, which means integer location. So let's say that we want to access the first row and the first column. We want to access the value in the first row and the first column. If we run this code, we will get the value of no. And you can see here that this is correct. First row, first column, value of no. And of course, it's a string. Let's say right now that we want to access the second column. Let's run this. 0. Lovely. So essentially, in one simple comment, you can see here that ilog uses integers to access row column pairs, where log uses the strings to access row columns. And all of this using indexes and column names. Okay, so this is very, very simple. Very, very simple. And this is how you usually parse and use your data frames. In most cases, you are gonna use your data frames using this method, using high lock and lock, and only if you want to filter out data, you are gonna use methods like filter and all of this stuff up here. I hope you enjoyed this tutorial. Don't forget to subscribe and check out the other tutorials in the description. Hello guys, in this tutorial we're gonna be seeing how we can update the rows and the columns of the Pandas data frame. So the first thing you want to do is open up your code editor and import Pandas as PD. What this code does is that it imports Pandas and names it PD. So after you do that, you load up your data frame. In my case, I have created an example data frame. You can type it out here. So pause the video and get this running. So let's run these two code lines. As we can see, this data frame has 3 samples and 3 features. Samples and features mean rows and columns respectively. So let's say that we want to change the column names of this data frame. So we want to replace these 3 texts with other kind of texts. How can you do it? You can use df.columns equals a new list. So for example, let's name it name1, age, sex1. So let's replace the columns of the data frame with these 3 new names. Shift enter to run the code, and boom, we've got the new columns of the data frame. There's another way to do this operation. You can use df.rename, and for the argument columns, you will equal it with a new dictionary. One of the best things you can do with rename is that you can actually change only 1 or 2 or 3 of these column names. And you won't have to change all of them as we did here, because in this method you have to change all of them. So for example, let's say that we want to change name1 and name it name. So what you do is that you pass a dictionary with your current naming of the column and the new naming of the column. So if you run this code, the resulting data frame will have the new column. So it will change name1 and turn it into name. But make sure to understand this code by printing the data frame in a new way. So you can see that the original data frame has not changed. The f.rename by default returns a new data frame and does not change the previous one in place. So if you want to change the data frame, what you want to do is call rename and also specify the argument in place equals to 1. So what it does, it changes the original object, the data frame, and does not, but it also returns that data frame as well. So if you run this code and again call df, you will see that you have changed the name1 back to name. So that's how you can change the names of the columns. Now let's see how we can manipulate some elements using rows. So for example, let's say that we want to replace this row, the row with index 2. So what you want to do is use the lock argument. So what you want to do is access the second index, the second index in the data frame. How you do it? df.lock2. If you want to see a lot more stuff about accessing elements, you need to see one of my previous tutorials on Pandas. Let's say that we want to change the third row with index 2 to a new one. We call df brackets 2 equals, in this case I will use a list and I will say arrow for the first element, age will be equal to 26, and I'm gonna be a male. So if you run this code and print the data frame, you see that the operation is done in place. .lock and .ilock do these transformations in place, and you can see that we replaced this row with this specified one using a list, and boom, we successfully manipulated the data frame. You can also do that for specific columns. So for example, if you have df lock, you can also use a list to specify which of the columns you want to change. So we can specify using a list the column age and sex. So what this will do is go and replace the value specified by a list only for those two columns. So in our case, we have age 1 and sex 1, and we are going to be replacing the values of this row with index 2, and for only the age 1 and the sex 1 columns. So it's going to be from 26 male, it will turn to 25 neutral. Let's check this out. Let's print the data frame. Boom! You just have a new data frame with a new information only for those two specified columns. Another way to do that, but only accessing a single pair of rows and columns, is the operation .add. So you can use .add, specify the index and specify the column. You can only specify one index and one column. However, with lock, you can specify multiple columns or multiple indexes. So in this case, we want to change the age, and we are gonna do it from 25 to 30. Let's print the data frame as well. Okay, so we got age 1 here. So let's run this again. And you can see here that we have age 1 equals to 30. Okay, so now we have an extra column that I'm gonna be dropping right now real quickly fast. And this is how you can drop, extra columns from your data frame. What you do is df.drop, specify the age, and then put the axis equals to 1 because it is a column, and also say in place equals true or 1. So the data frame will be manipulated in place. It will actually change the data frame object and return the data frame without age 1, sex 1, and name. So okay, I will be using. So what this does is. So what .drop does with in place equals true is that it changes the actual object, and boom, we removed the age column. Before we finish the tutorial, I want to show a very common error. So what is this common error? Let's say that, for example, you use some filter operation, like for example, df for the age column, we want only those which are equal to 30. For example, the final row will be true and the others will be false. So if you print out field, in this case, we will have false, false, true for each index. Then, if we want to filter out this specific column and also use age 1 and equal it to 27, what essentially we try to do here is set this value here, third index, third row, second index, age 1 column equals to 27. However, this will not run as expected. Python will throw an error that you try to set a copy without warning. The problem here is very simple. When you use only brackets, what you do is essentially try to access specific elements. So the return of this will be a copy of the data frame. It will not be the location in the actual data frame. So when you want to set new elements, you use .add, .lock, .idlock. You do not use only square brackets because this will change only the copy of the object. And as you can see, the original object here doesn't have the value 27 in the second index, third row, age 1 column. So this is a very usual error. What you want to do is use the lock function with field for the indexes, age for the column, and equal it to 27. This will run perfectly okay and will change the element. So again, I did the same mistake because in my examples I've used the age only. So let's run it again. And yeah, you see here that we have the value 27. Again, let's go and drop the age column that we do not need. And also let's go and rename all the other features because it's really tiring at the moment to turn every example back to the original. So sex1 will be turned into sex, and again what you want to do is use in place equals true. Did I do a mistake? Yes, I do not need this line anymore, and let's use df to view the data frame. Boom, we are good to go. Again, before finishing up, use lock and tielock to change the data frame values. Don't use brackets because it is a copy of the object. Okay, so you use lock and tielock to change the data frame values. Hey guys, so in this tutorial I'm gonna show to you how you can add, remove rows and columns from a data frame. The first thing you want to do is import pandas as PD. After that you want to specify some kind of data frame. You can use your own one or use this one. Okay, so you want to be specifying this data frame, so shift enter to run the code, and boom, we've got our data frame here. We have 3 columns and 3 rows. So the first thing we want to do is try and create a new column using the existing ones. So let's see. Let's say that we want to combine the name and the sex columns. What we want to do, because these are strings, is actually add them as strings. So we call the df name, we use the plus, we put a space between those 2 columns, and again call df sex. So essentially what this is gonna be doing is use this column, add a space, and also after that add the column sex and return a new object. Okay, so that's essentially what this code did. And you can actually use it to add a new column here. So what you do is very, very simple. We say extra column, we say data frame, brackets, extra column, you can use any name you want here, and it does not need to exist inside the data frame. This is really important. It will by default create a new column if this column does not exist in your data frame, and you want to put it equal to the column we created above, and then print out the data frame. Boom, you've got the extra column, which is a combination of the name and the sex. Now let's see how you can remove this let's say column. What you do is very, very simple. You use the DataFrame.drop method. You use columns argument equal to a list which will be extra column. So what you do is specify a list which will include the strings, or actually let's say the names of the columns you want to drop. And because it is columns, we use the argument columns. And you also can specify the axis equals to 1, which means columns, just for safety reasons. Okay, so let's print out the data frame. Oh, wait a minute. Why is the data frame not having changed? We use the .drop function. Yeah, as we've seen in previous tutorials, what you want to do here is specify an argument in place. So in place argument by default is false because the .drop operation returns a new data frame. But if you use in place, what this operation will do is go into the memory and change the data frame object as it is in the memory. So let's run this code again. Boom, you can see that the data frame object has actually changed. So if you want to change the actual object and not get a new one, what you want to do is use in place equals true. Okay, so let's talk a little bit about .append, which is a deprecated function that you won't be using in the future, and adjust showing it to you for encyclopedia reasons, let's say, just for knowledge. .append allows you to append rows to a current object. So you call DataFrame.append, specify, for example, a dictionary. I will call it dictionary. You can use a dictionary for this, and you specify for each column the values it is going to take. Bear in mind that the key of the dictionary will be equal to a column in the data frame, and the value should be a list because it should be an iteratable. So here I will specify that the new row I'm gonna be appending has the name George. It will also have a value for age, which is gonna be 25. And after that, I'm gonna be specifying its sex. So it's gonna be male. It's gonna be male with not capital M. And boom, this is how you can append a new row to the data frame. Oh, wait a minute, an error. You need to ignore the index. Okay, so if you want to append a dictionary, you need to ignore an index. If you had, for example, been appending another data frame, it could be able to use the indexes. It would be able to use the indexes of the two data frames. And also you can see here that I made a mistake. In this case, you may not want actually the list example. And as you can see here, we have appended the new row. And again, this is deprecated, it will be removed, so use pd.concat. Okay, so let's use pd.concat to concat. Okay, so let's use pandas.concat to do the same operation. And I really like this operation here with .concat. So let's specify the new row. It will be equal to a dictionary. And now let's specify the dictionary. So for the name column, we want George. And right now in this case, you want to use, the list specification using the brackets. Then you want age, which is like that. And age will be equal to 30. And then you want to specify the sex of George, and it will be, let's say male. One thing I want you to note here is that .append does not do operations in place. So if you print out the data frame, it will be not new. It won't have changed. The data frame, the original one, using the .append has not changed. If you want it to change, you need to do data frames equals data frame.append. Okay, so that's also one of the reasons it's gonna be deprecated. So we specified the new row that we wanna be appending. Let's create actually a data frame out of it. So you can create a new data frame using a dictionary, just like that. So you put new row inside of the wrapper pd.dataframe. And let's concatenate. So you use pd.concat tmp.df access equals to 0. Okay, so let's talk a little bit about that. The .concatenate can concatenate two data frames or a data frame and a series into one data frame. So what you pass as the first argument is an iteratable that contains either series or pandas data frames. In our case, we have a list of two data frames, and we say that we want to concat them line by line. So what this will do is get the temporary, what this is going to do is get the TMP data frame, and for each row of the data frame called df, it's going to be appending rows, and it will return a new data frame. So the result will be a new data frame. One of the problems of the new data frame is that the indexes are all messed up. Both the TMP and the first element of the F have the same index of 0. So first of all, in order to fix it, we use ignore index equals true. So it's gonna create a new index on the final data frame, and you can see that this is fixed. Also, we have not saved the new data frame into a variable. So let's call this df3, print df3, and we have saved the new data frame in this variable df3. And let's see after that how you can remove a row in the data frame using the index. You can use df drop index equals 0. So what is this going to do? It's gonna go find the index 0 and remove it. Let's run this code. Oh, it removed from the original data frame. So we want to drop actually the index from this data frame. Okay, df3, boom, the index is removed. Okay, let's print out df3 again. Oh my god, df3 actually still contains the first index. Okay, so how are you gonna save this? You wanna go here and put in place equals true. Okay, so now df3 is gonna change because we use the operation in place. If you do not use in place equals true, it's just gonna and return a new object like df3, but having removed this index, the index 0. Alright, so this is how you can also drop rows from a data frame. And there is also another amazing way. For example, you can also use a filter operation. So for example, let's say field equals df where age is over 30. And what you wanna do here is use the index. So okay, let's talk a little bit about what this filter operation does. So first of all, it's gonna go inside df3, specify df3 please, and it's gonna look at the age column. And it's gonna return a false value for each index where df3 is not bigger than 30, and the true value where df3 age is over 30. So it will be false, true, true. So if you use the dot index, you can actually access the index of a data frame. So the filter method here, it will have the indexes of second and third, because these two will be true. If I print this out, check it out a little bit, it will also return, it will only have the elements of df3, 2 and third. If you use the dot index, you just get the indexes of those two elements. So if you go back up and use the df3 index, instead of this index, you can use the field index. Oh my god! You can actually drop the second and the third index by using this operation. Let's run this. And it will be done also in place, which is absolutely amazing. Boom! Our data frame now has only the first index, or let's say index equals to 1, and those elements, all the others have been dropped. So this is how you can use a filter method to drop multiple rows. Okay guys, so in this tutorial we're gonna see how you can use summary statistics in Pandas Python. First of all, what I want you to be doing is importing Pandas. So import Pandas as PD. After that, I want you to specify a data frame. You can use your own one or pause the video and try it, the one I'm gonna be using right now. So let me go and take this data frame. Great. And I'm gonna be using this one. It has a string, a column with name, and another two columns with numbers. Boom. So this is the data frame that I'm gonna be working with. So let's check out the first summary statistic. You can use the f.mean function to find the mean for each column. Of course, age and height will have a mean because they are numeric columns. This function is gonna be ignoring every column that is not numeric. So the mean of the age is 38 and the mean of the height is 100. We can check out the data and this is probably correct. You can also check the mean for a specific column using the brackets notation. So you can access a specific column using the brackets and the name of the column, and then use the dot mean for only that column. And again, it's the same as in the most general function call. After that, you can use summary statistics like mean. This way you can find the mean for each column, or dot max to find the max. Or you can use something that I or you can use .describe, which I really enjoy because by default it has a lot of summary statistics. like the count of elements, the mean values, the standard deviation, the minimum and the maximum, and also some statistics about the quantiles and the range that these values take. And a great thing you can do with df.describe is that you can use the log function to access specific rows of this data frame. So, for example, you may only want mean. You can access mean by using the .log function we have learned in the other tutorials. And you could also do something absolutely amazing. First of all, I want you to be specifying this specific data frame because I'm gonna be teaching you a very simple example about group by. So run this code, and then what you wanna do is from this data frame, just keep the sex column and the age column. Okay, so you are gonna be putting a list inside of the brackets. So now the data frame contains only sex and age. You wanna be grouping with sex. So you use .group by parentheses and call the value of sex and compute the mean. So what this is going to do, it's gonna show you the mean age for each sex. So this is an aggregation operation. So females by default are 58 in our data and males are 28.5 years of age in our data. Another thing you can do with summary statistics is find the value counts. So for example, if we specify data frame brackets and the column we want, we can find how many counts are for each specific element in the sex category. So in our sex category, we have 2 males and 1 female. So the result of this will be male equals 2 and females equals 1. Boom! Exactly. We have 2 males, so that's what value counts does, and 1 females. It counts the number of occurrences of each distinct element in a column. And an alternative way to do this is grouping by sex, accessing only the sex column and doing the .count operation. The result will be pretty much the same. The only thing that changes, I think, is the resulting type. So for example, here we have a pandas.series, but down below I do not know. So let's run this code using the type. Okay, so both of these are pandas series, but there is a small distinct difference. Here we have sex, and we have the sex here as well. Maybe I need to do this, I'm not sure. No. Okay, so there is a small distinct change into the specification of the series object returned. But yeah, so that's pretty much what you wanna be doing to find the value count, and also using grouping by to find some mean statistics per specific parts of the population. I hope you really enjoyed this tutorial. Press the like button and subscribe. Let's see how you can use plots in Pandas. The first thing you want to do is import a data frame and also import the Pandas library. So I'm gonna be writing here pandas as pd. That's how you import pandas. Let's run this. Second step, specify the data frame you wanna be running around with. For most of these plots, you will need a data frame with numeric values. So I specify this specific data frame. You can also specify yours. If you do not have any data frame, pause the video, copy paste this code and run it. First and most simple plot you can do, run .plot function. Use the name of your data frame, .plot. Let's check it out. And you can see here that by default the plot function only cares about the age column. On the x-axis we have some dummy values, and the z-axis we see the values of y. We can also do that more implicitly just in case we have multiple numeric variables. What you do is actually use the brackets to access only the specific column you want to plot. Okay, so here you can see exactly the same plot. Okay, so now let's specify that we want the index to be. So now we're gonna specify the index. So we are gonna be using the first column, the column of name, equals to an index, and we are gonna be doing this in place. Okay, now let's plot the data frame again, and we can see here that each element on the x-axis actually has the index by default. So now our index is the specific row index. So this row has this value, this row has this value, and this row has this value. Great, let's move on. I'm gonna be specifying a little bit different data frame. Instead of the column sex, I'm gonna be adding a height column with some more numeric values. So in your case, you wanna be having at least a data frame with 2 numeric features to go along. You can also specify this one. Pause the video, run it down, and continue running the code. Now, what we want to do is actually see how these 2 numeric features are being plotted on a 2D axis. So what we are gonna be doing is using the function scatter. So let's check it out. You use df.plot, and from the plots you wanna access the scatter plot, which is a different kind of plot compared to this, let's say, line plot. First, you specify the column at the x-axis, and also you can specify the column at the y-axis. And the alpha is just for the coloring, putting a little bit less stable colors. And here you can see a plot in the 2D axis, meaning we have x and y axes, and we can see for each element the combination of height value and age value. Lovely. We can also have an alternative view by using the box function. So the box function is a great function if you want, to get some statistics for each column. So this green line is usually the median value. This is the quantiles, 25%, 75%, and this is the 5% and the 95%. So it also gives you some confidence intervals. Also, bear in mind that if you run this in a Python file and not a notebook, what you want to do is use .plt.show to show the plot. And you want to be importing matplotlib.pyplot to do that. However, if you use notebooks or Google Colab, this is done by default. But let's see an example. So what you're going to be doing is import matplotlib.pyplot as PLT, specify a plot, and get the figure and the axis. Again, we want to plot the age value, and I'm going to be checking about an area plot, which I really don't know what it does, but let's check it out. And specify the axis using the AEX argument equals to the axis of the plot we want to be showing. Then you can specify also a label for the y-axis, and we are going to be equaling it to a string called value, and then use plt.show. Let's check this out. Boom, so this is an area plot. Okay, so we have the value, we have an area, which could be seen like an integral, and we also on the y-axis we have the indexes for each, value. Lovely stuff. Okay, so let's try it for the height column as well. So we are going to be creating a new plot the new area using the new axis. And okay, so we can see here the trend for the height. Lovely. And one other thing you want to be doing is plotting both those variables inside the same plot. So you can see here that age will be blue and height will be orange, and you can see here how those 2 values go about. So this is a very great way to find correlations. Let's say, for example, if those values were both uptrending or downtrending, this is a correlation. So this is how you wanna be plotting about using Pandas.